Okay, algebras, here's our third way of solving linear systems. We can call it elimination, or sometimes you'll hear it as linear combination. Most kids like this method better. They think it's fun to eliminate or cancel out one of the variables. All right, our first step is we're going to arrange the equations with like terms in columns. X's with X's, Y's with Y's, equal signs with equal signs, and constants with constants. You want to make sure that everything is lined up in columns because you're going to be adding the equations and you need like terms. The next thing you might need to do, depending on your values, is you're going to have to multiply each equation by a number. And I want you to think about a factor, because what you want to obtain is a zero pair, or you want opposite coefficients for one of the variables. Your goal here is that one of the variables will cancel out. You're looking for a way to eliminate a variable, so you're going to be hoping that they can cancel out. So if you have a 2x in one equation, you're hoping for a negative 2x in the next equation. Once you have your opposites or your zero pairs, you're going to add the two new equations. Your next step is then you will be solving for the second variable. Once you have a value for one of the variables, you can substitute that value from here into the original equation and solve for the other variable. Remember, your solutions are always an XY ordered pair, and you can always check your solutions in both equations by substituting and simplifying. Okay, so these first ones are really easy because here I have my zero pair. If you look at here, my X's and Y's are all lined up, but my Y's have zero pairs, positive 3 and negative 3. When I add those equations, they cancel out. 6x is equal to 24. Divide each side by 6. X is equal to 4. I have a choice of which equation I want to use, and you can choose either one. They're both guaranteed to work. I'll go ahead and I'll choose 2 times x minus 3y is equal to 8. Use the entire equation, even the value of the variable that you eliminated, and then you can go ahead and solve. 8 minus 3y is equal to 8. Subtract 8 from each side. The opposite of 3y is equal to 0. Divide by negative 3. Y is equal to 0. Therefore, your ordered pair is an x value of 4 and a y value of 0. There you go. Now you can see. Sorry about that. Alright, next up, we'll do this one. Here's my zero pair, positive and negative y. We'll go ahead and add the equations together. 6x's and 3x's are 9x's. My y's cancel out, and I get 9. Divide each side by 9, and x has a value of 1. You can choose either equation to substitute in. I'll pick this one. So 3 times my value of x plus 2y is equal to 7. 3 plus 2y is equal to 7. Subtract 3 from each side. 2y is equal to 4. Y is equal to 2. Therefore, my ordered pair, my solution for this equation is 1, 2. Alright, let's take a look at 3. When I look here, my x's are lined up, my y's are lined up, my equal signs, my constants, but I don't have a 0 pair. I have 4 x's and negative 2. My signs are opposite, so what I'm going to do is multiply this equation by a factor of 2. That's going to make it negative 4x plus 2y is equal to negative 4. Now I'm going to rewrite my first equation. Don't be lazy and think that you can squeeze it in or do it in your head. When you take the time to write it out, your neat work makes it a lot easier. Here's my 0 pair. So I have 5y's is equal to 20. Divide by 5. And my y is equal to 4. Now notice it doesn't matter if I cancel out y's like I did in the first two or x's. You get to choose whichever variable you want to cancel out. And somebody might choose a different one than you, but you'll be guaranteed to get the right answer every time. I'm going to substitute back into my original equation. Negative 2 times x plus the value I got for y is equal to negative 2. I got 4 for y. If there's no coefficient here, there's no multiplying. Those parentheses are actually unnecessary. Don't let them confuse you. I'm going to subtract 4 from each side. Negative 2x is equal to negative 6. Divide by negative 2. And x is equal to positive 3. Therefore, my solution, 3, 4, is where those lines intersect. Alright, let's see. My x's are lined up, my y's are lined up, my equal signs. All I need now is opposites. So I'm going to go ahead and multiply this equation by a negative 1. That's going to make negative x plus 3y is equal to 0. You could have chosen the other equation. That would have been fine. There's more than one way to solve these problems, just as long as your math is set. Here's my 0 pair. 13y's is equal to 13. Divide by 13. Divide by 13. Y is equal to 1. You can choose either equation. I'll choose this one. So my x value plus 10 times my y value is 13. X plus 10 is equal to 13 minus 10 minus 10. X is equal to 3. Therefore, over 3 up 1 is the solution. Alright, so let's flip it over and solve these ones that are on the back. I have A's and B's. It's your choice what you want to cancel out. You can work on having the B's be opposites. Because these A's are already 1 positive, 1 negative, I'm going to multiply this one by 4. And I'm going to multiply this equation by 3. Can you guess what I'm going to have as my variable coefficients that are going to cancel out? When I distribute 4 to every term in the equation, I get 12a plus 20b is equal to 24. When I distribute my 3, I get negative 12a, there's my 0 pair, plus 6b is equal to 15. When I go ahead and I combine, away they go. 20 and 6 is equal to 26 b's. 39 divided by 26 divided by 26. So b is equal to this fraction. They can both be divided by 13. Now, if that's not something that you know, go ahead and get your calculator and type in that fraction. 39 divided by 26. It doesn't go in evenly, but that's a decimal you recognize. Math, frac, enter. B has a value of 3/2. Alright, so I'm going to take that and substitute that back into my equation. I'm choosing this equation because this denominator and that coefficient are going to make things work out nicely for me. I'll write my equation. I'll put my value in. For b, I can go ahead and write that over 1. Multiplying fractions is no problem. Top times top, bottom times bottom. And of course, this simplifies to 3. The calculator can also help you do that math. 2 times 3 divided by 2. Don't be afraid to use the calculator. Subtract 3 from each side. Negative 4a is equal to 2. Divide by negative 4. Divide by negative 4. A is equal to negative 1/2. So my solution is negative 1/2 and 3/2. It's okay if they're fractions. Things don't always work out evenly. Alright, so let's take a look at my Q's and my R's. I could use either one. Maybe I want to go for a common coefficient of 13 and cancel my R's out. Or maybe I want to do my Q's. Either way will work out. I think what I'm going to do is have my Q's cancel out. I'm going to multiply this equation by 2. That's going to give me 6 Q's minus 10 R's is equal to 16. I'm going to multiply this equation by 3. That's going to give me negative 6Q plus 9 R's is equal to 9. Finding this coefficient that's common should feel a little bit like a common denominator. Thinking about what is the smallest number that both of these coefficients go into. When I add, those cancel out. Now all I have is R's in my equation. That's good news. That's what I wanted. Divide by negative 1. My R is equal to negative 25. You can choose either equation to go ahead and solve for. I think I'll choose my first equation. So 3 times Q minus 5 times my value for R is equal to 8. So that's 3Q plus 5 times 25 is 125. I'm going to subtract 125. So 3Q is equal to, when I bring my calculator in, 8 minus 125 is going to be negative 117. Let's see if that's a friendly number with 3. Sure is. Divided by 3, divide by 3. So Q is equal to negative 39. Now I gotta tell you, I'm a little suspicious about this answer. The numbers seem weird to me. If I talk about, usually with QR, we're going to go ahead and write our ordered pair in alphabetical order. So we'll say negative 39, negative 25. If I want to test to see if I did it right, all I need to do is go ahead and do 3 times my value for Q minus 5 times my value for R, and I get 8. So that's a good way of checking. We can check it here too. Negative 2 times my value for Q, and that's going to be plus 3 times my value for R, 3. So I know I did it right, because those two values, when I put in for Q and R, give me true number sentences. Alright, let's take a look at 7. When we look at 7, this one's a little tricky because I have my x's and y's and constants lined up, but not my equal signs. Check it out. So I'm going to need to do some rearranging. I need my x's and y's on the same side, so I'll go ahead and subtract y from each side. That gives me 2, or x plus 2y is equal to 5, and 5x minus y is equal to 3. Now I'm all lined up. So step 1 is to arrange my equations. Now I'm looking for a zero pair, so I'm going to multiply this second equation by 2. So when I find that coefficient, x plus 2y is equal to 5, I'm looking for a zero pair. 2 times 5 minus 2y. Here we go. Zero pair is when you add them together and you get 0. 11x is equal to 11. Very nice. Divide by 11, x is equal to 1. Now it doesn't matter which equation you go back to, but after you solve and you get this value for the variable, you're going to go ahead and substitute it in to your next equation. I'll say 5 times x is equal to y plus 3 minus 3 minus 3. 5 minus 3 is 2 is equal to y. Therefore 1, 2 is your solutions. Alright, take a look at 8. I've got 4g and h, and g and h and 5 and 0. Everything's all kinds of messed up. Let's add an h to each side. 4g plus h is equal to 0. And let's go ahead and add a 5 to this side and combine these constants. I get g minus h is equal to 5. Check it out. I have my zero pair. Here it is. So positive h and negative h are going to give me 0. 5g is equal to 5. G is equal to 1. It doesn't matter which equation I go back to. So I'll say 4 times 1 is equal to the opposite of h. So 4 is equal to the opposite of h. Divide by negative 1. And I have h is equal to negative 4. Therefore, my ordered pair in alphabetical order of GH is going to be 1, negative 4. Alright, last problem on this page. What is the solution to this system of equations? Now, I could go ahead and solve it if I wanted to. I could go ahead and graph it, or I can plug and chug. I have 3 different options available to me. I'm going to go ahead and solve it using a system of equations, and I'll go ahead and find a common coefficient for my x's. So I have negative 6x plus 3 times 12 is 36 y's is equal to negative 90. My second equation is going to be positive 6x minus 8y is equal to 17 times 2. It sounds like 34 to me. When I add my equations, my x's cancel out, and I have 36 minus 8, that's going to be 28 y's And let's see, I have negative 90 plus 34 is going to give me negative 56. When I divide that by 28, that's going to give me negative 2. So my y value is equal to negative 2. So, oh great, I was only able to eliminate 1. So I'll go ahead and plug back into any of these equations to solve for x. So 3x minus 4 times negative 2 is equal to 17. 3x plus 8 is equal to 17. Subtract 8, subtract 8. 3x is equal to 9. X is equal to 3. So here we go. All right. Good job. Make sure you do your homework. Come to class with questions.